All right, AP Chemistry, this is your lesson on gram stoichiometry. It was the one given of Wednesday of last week and Wednesday of this week. You only have to do it once. And this is due, actually, I'm going to let this go until Monday. I was kind of on the fence about that, but I'm getting the solutions up here on Thursday. So you have until Monday, but you are going to get 2 more assignments on Friday. And by the way, I'm going to be shortening the assignments a bit. So I'll talk to you about that as we go through this assignment. Okay, let's go ahead and get started on this. So the first 2 pages here are really just instruction. You can see they kind of mirror the video for Wednesday, how to do these types of problems. It's not a problem itself, but I start you off with the graphic organizer that you saw in the video, show you how you set these problems up. Okay, so this is kind of static. It's just printed on the page. The video shows you kind of an animation of how to do it, and I think that might help you a little. All right, so we're going to go ahead and get started here with this particular equation. So 2Ag plus 1H2S is 1Ag2S and 1H2. All right, so you see the graphic organizer. So we measure things in grams out here. This is our world. Inside the dashed line is the chemical equations world. It's counting particles, either molecules or atoms, and putting them together. So it goes out, it gets two Ag atoms, puts it together with 1H2S, and that reacts to produce this. So it's counting numbers of atoms and molecules. That's what a mole is. It's a big basket of 6.022 times 10 to the 23rd atoms or molecules. So it's matching up. It's putting together things based on numbers, not based on weight. We can't count numbers as big as a mole. We can't see things as small as an atom or molecule. So what we have to do is use we have to have a way to do that, and that is we measure things in grams. And if we know 2 things, how many grams a substance weighs and exactly what that substance is, whether it's a pure element or a compound, as long as it's a pure element or a pure compound, there's nothing else mixed in with it, then we can do this conversion. That, for example, silver, you get this number straight off the periodic table. 1 mole of silver equals 107.9 grams. And so that gives us a translation between grams in our world and moles in the chemical world. You can also come back out in the other direction here. All right, so let's go ahead and get started with this one. The first instruction is balance the equation. It's not necessary. These are all balanced equations. And then you do this the way it's done in the video. So let's just get started with this. By the way, on this sheet, which I have posted, this is a worksheet version. It leaves you enough space to write on the sheet. If you want to print it out, it's going to be about 9 pages, but it leaves you a lot of space to actually do your work on the sheet. Otherwise, you can copy it on a piece of paper if you wish to do it that way. What I do want to see you do is solve these problems exactly the way I'm solving them here. No shortcuts. They've got to be solved exactly the way I'm doing it here. All right, so let's get started. How many moles of H2S are required to produce 3.5 moles of Ag2S? So you want to know how many moles. The question mark is how many moles of H2S required to produce 3.5 moles of Ag2S. I don't have to write unit of measure because this is in moles and this is the substance. That tells me the substance. So you can see it's a one-step problem. Now remember, the chemical reaction flows from left, which is reactants, over to the right, which is products. But a math equation is going to flow from what we know to what we don't know. So what's going to go on the left at the beginning of the equation is this, 3.5 moles. So I'm going to go ahead and write that here. And it's always unit of measure and what the substance is in parentheses. What I'm trying to find over here is moles of H2S. So I'm going to come way over here. You don't know how much space sometimes you need until you're experienced at these. Okay, and that's what I'm trying to find. We see it's a one-step process, so I'm going to put 1 box in here. And I know it's going to be some sort of ratio, so I'll just draw a line right there. So our conversion is between moles of H2S and moles of Ag2S. And we see the relation right here. There it is, and you can create two ratios. The only assignment where I'll ask you to write this out, this longhand like this every time, is this one. Okay, so I have two ratios that are both true statements. There's 1 mole of H2S for every 1 mole of Ag2S, or there's 1 mole of Ag2S for every 1 mole of H2S. Which one are you going to put in here? Think about it. Okay, you want moles of Ag2S to cancel out, to go away, and you want to end up with moles of H2S at the end. So which one does it? It would be this one. Okay, so Ag2S on the bottom and Ag2S on the top. Remember, if it's only one level to it, it's on the top. It's in the numerator of a fraction. So that cancels moles Hg2S with, this is the last man standing. Moles of H2S is what you want in your final answer. So very simply, the problem is 3.5 times 1 divided by 1 will give you 3.5. Okay, and that's how you answer that one. All right, let's go on to the next one. Before we do, let's erase the markings we made in the graphic organizer. That's optional for you to do, but I recommend you do it on this assignment. Be sure you see how the problem is flowing. All right, we're going to move on to part B. And the question, I had to correct it here, so note this correction. How many grams of Ag will produce 4.67 grams of H2? Okay, so we're trying to find grams of Ag. How many grams of Ag? So here's Ag, silver, and grams is down here in our world. So it's asking how many, so I'm going to put the question mark there lightly. And it will produce this many grams, 4.67 grams of H2. So here's H2, here's grams, so I put 4.67. I don't need to put unit of measure there because it's in grams, it's in the grams row, and it's under H2. All right? Okay, so what is the path we're going to have to go? We're starting, even though the chemical equation is flowing from left to right, it does in fact flow from left to right, our math equation is going to start with what we know and flow back to here. So we start with 4.67, we use the molar mass. Now note something here. The molar mass is the mole of one molecule. That's 2 hydrogens. That's what an H2 is. So it's 2 hydrogens, so it's 2.02, not 1.01. So we go through the molar mass to get the number of moles of H2. Now, once we're in here, we know a relation between H2 and Ag. It's the only place we do. You have to come into the equation. We move across the equation to here to get moles of Ag, and then we use the molar mass of Ag to come back out. Now, another note about this. Molar mass is always 1 mole equals some number. That number you'll get straight off your periodic table if you look at silver. Don't get fooled and use 2 moles. Molar mass is always 1 mole. It's equating 1 mole to some number of grams. Okay, the 2 moles will come into play in the equation, as you will see. Okay, so here we go. So we first have to go, we're going to start with 4.67, and I'm going to write it way over on the right here. I'll try to stay on screen. So I start with 4.67 grams of H2, and I need to get to some number of grams of Ag. So I'm going to put a little question mark there. Oops, there we go. And it's grams of silver. Okay, so now we have 3 conversions. We just talked about them. 1, 2, 3. So I'm going to put 3 boxes. Grams to grams is always 3 conversions. And we know we're going to put some ratio in there, so I'm going to go ahead and draw my lines ahead of time. Okay, and now I'm ready to start. So the first one is going to be a molar mass conversion. So there's the conversion factor. So I'm going to just write the ratios down below. So it's 1 mole Okay, so there's the two conversion ratios I get out of that conversion factor up there at the top. Okay, so here we go. So which one of these goes in here in order to make grams of H2 cancel out? We know that has to go away because it's not in the final answer. Okay, we need grams of H2 to cancel out with this, so it's going to be 1 mole of H2. It's okay to make mistakes, just try to catch them as early as possible. You'll see me make plenty. Okay, so there we go. So it is this one. So grams of H2 cancels with grams of H2. That leaves us now with moles of H2. So as you saw in the video, I did these step by step along the way. I'm not going to do that here. So right now we know this. This is where we are in the equation. Now we need to get from moles of H2 across to moles of Ag. That's the only relationship we know inside the chemical equation. So the relationship is there's 2 moles of Ag equals 1 mole of H2. So let's come down here and write this. And now we write two ratios. Okay, so these are both true statements, these ratios, but which one fits in here to advance this through the equation? Well, we have moles of H2 up on the top. We need that to cancel because it doesn't appear in our final answer. So that means we need moles of H2 on the bottom in this equation down here. So it's going to be this one. And moles of H2 cancels with moles of H2, and I'm left with moles of Ag up on the top. So that means I'm sitting right now in this box right here, and my last step is to come out to get to here using the molar mass conversion for silver. So you already see the conversion, so I'm not going to write it again. I'm going to just write the ratios. Okay, so my two ratios kind of slipped over to the side here. So which one of these two is going to go into that last box? We need moles of silver to disappear to cancel. And we need grams of silver to appear on the top for the final answer. So it's going to be this second one over here. So we're going to put that up there. Okay, so moles of Ag cancels with moles of Ag. The last unit left is grams of Ag, which is in your final answer. So now I'm ready. Now that I have the units lined up properly, I'm ready to compute the numbers. So, by the way, this does not look like a 6. That is a 6. So I'm starting here, and I'm going to multiply everything on top, divide by everything on the bottom. 4.67 times 1 times 2 times 107.9. Now I divide by 2.02, divided by 1, divided by 1. And of course, you all know divided by 1, you really don't have to do that, but let's do it, okay? And I get 499. I'm just going to go to 3 significant figures. Grams of silver. All right, let me make a point, by the way, about significant figures. Whenever it's a measured value, you do have to consider significant figures. 2.02 is 3 significant figures. 4.67 is 4 significant figures. But what about numbers like this, which are simply a relationship between moles and moles? These are not measured values. You're simply saying in the equation there's 2 moles of Ag for every 1 mole of H2. Do those count as one significant figure? The answer is no. They're not measured values. They're simply a relationship values of 2 moles to 1 mole. So these actually have an infinite number of significant figures. In other words, they don't limit your significant figures. The only ones you would use are the actual measured values, which this is a measured value. It could be measured more precisely if you had a good enough scale. This molar mass relationship. The number we're starting with is a measured value. This is a measured value. You could find some periodic tables that have that to more than 3 significant figures. So those are measured. Those count as significant figures, but these don't. This 1 mole doesn't, this 2, this 1. These just nice integer numbers like that are not limiting your significant figures. Okay, let's move on. And it's how many grams of H2S are required to produce 8.3 grams of Ag2S. So it's asking how many grams of this are required to produce, whoops, wrong place. By the way, you want to erase your anything you've written before for the previous problem. So it's asking how many grams, so we need to be down in the grams row of this substance is required to produce, and it says 8.3 grams of this. So our path is again 3 steps. We cannot go directly across. We don't know a grams to grams relationship. We only know moles to moles relationship. So we have to go from grams into moles using molar mass, go from moles to moles inside the equation. You can only go sideways inside the equation. And then we have to come back out using the molar mass of H2S to give us that answer, okay? I'm going to write this one out silently and quickly, and you can follow it, and let's go ahead and do that. Okay, I didn't leave myself a lot of space here, and that happens. But I need to convert this. I need to put that into ratios, so I'm kind of crowding it over here. Okay, so it's, I'm sorry, this one, 34.09. Okay, so let's get up here. These are my 2 conversion ratios for this last conversion. Come out again. So which one do I need? I need moles of H2S to cancel and grams of H2S to appear in the final answer. So that means I'm going to pick the second one right here. Let me get this on screen. We're challenged here. Get that. That's the one I need, okay, with moles on the bottom. All right. Okay, so moles of H2S cancels with that. Grams of H2S is the last man standing right there. So everything is set up properly. So we're going to go ahead and compute the numbers. So it's 8.3 times 1 times 1 times 34.09 divided by 247.87 divided by 1 divided by 1. So we will go ahead and do that. and I get 1.14 grams of H2S. Okay, so the lesson to this is I should have started by, if I'm going to write all these out, I should have started way over here. Use all the space that you have. Okay, all right. If you're not using this sheet with this much space, by the way, you should be doing it on lined paper. There isn't enough space on the normal assignment sheet. Okay, let's keep going. Okay, D, how many moles of H2 can be produced by 6.52 grams of Ag? So let's come back over here. We'll erase the sheet. So it wants to know how many moles of H2. So that means the question mark is in the moles box under H2, and it can be produced by 6.52 grams of Ag. So here's Ag, here's grams, so 6.52 goes there. So in this case, both the math equation and the chemical equation are going from left to right, what we know to what we don't know. How many steps is this process? We have to get into the chemical equation, that's one step, and then from moles to moles, and we're done with this problem. So that's a two-step process. Okay, so let's go ahead and write this out. Okay, and we said it's two steps, so we're going to go ahead and put two boxes here. Alright, so our first conversion is using the molar mass of silver to get from 6.52 to some number of moles of silver. So there's the conversion. I'm just going to write the ratios. Now our final conversion is from moles of Ag to moles of H2, so that we have to use that relationship right there. Okay, which one of these goes there? Well, you need mole of H2 to appear in the final answer and mole of Ag to cancel, so you're going to use this one. That's the last one standing. So we can go ahead now and compute our final answer. 6.52 times 1 times 1 divided by 1.07 divided by 1. Should have said 107.9. Okay, and that gives us 0.06. Okay, and that's the answer there. All right, move on. Now we're doing a grams to moles here. So how many grams of H2 will be produced by 5.67 moles of Ag? Let's go ahead and erase everything we have in the organizer. And it's how many grams of H2. So here's H2, here's grams down here, so the question mark goes there. And it's going to be produced by 5.67 moles of Ag. So the 5.67 goes up here in the moles box. So what's our path? We start here, we go moles to moles across the chemical equation, and then from moles of H2 we come out using the molar mass to get grams of H2. So it's a two-step process. So let's go ahead and write that one. And it's two boxes. Okay, so first conversion is from moles of Ag to moles of H2. Same one we did in the last problem. Same conversion. 2 moles of Ag for every 1 mole of H2. So I'm going to go ahead and just write the conversions. Okay, we need mole of Ag to cancel out because it doesn't appear in the final answer. That means it has to be on the bottom. So it's going to be this ratio right here. Cancel that and that. Okay, now we have to get out of the chemical equation using the molar mass. There it is. Again, remember the 2.02 is for H2. Because hydrogen's a diatomic molecule. If it's gas, it's going to be H2. So it's not 1.01, it's 2.02. If that had just been a hydrogen atom, it would have been 1.01. So we're doing the molar mass of whatever that substance is. Okay, we need moles of H2 to cancel and grams of H2 to appear on the top for the final answer, so it's going to be this one right here. So the last man standing is grams of H2. There it is. So now we're going to multiply 5.67 times 1 times 2.02 divided by 2 divided by 1. And that gives us 5.8. Not too concerned with significant figures. It could have been 3. Remember, the only ones that significant figures count. So let's go ahead and write it out for 3. So it's 5.81. Okay, these don't count as significant figures. They're simply relationships. They have an infinite number of significant figures. It's exactly 2 and exactly 1. All right, let's keep going here. Now I'm just going to give you a heads up. There's only the first 3 problems are required, okay? The last 2 are optional if you want to practice some more. I will give solutions to those, but I want to get, first of all, let's focus on the first 3. So you see the word required. You didn't see that on the assignment last week. If you did it, great. The more practice, the better. All right, let's get going here. So how many moles of H2S are needed to produce 6.8 grams of Ag2S? Just fixing my graphic organizer. So moles, it's asking how many moles of H2S. So here's H2S, here's moles, so it's question mark for that. Are needed to produce 6.8 grams of Ag2. So here's grams of Ag2, 6.8 grams of Ag2. So the equation, again, the chemical equation moves from left to right, but our math equation, we're going to start here and move back to here. So we start with 6.8, molar mass gets us inside the equation, and then moles to moles gets us to our answer. All right? So let's go ahead and do that. So we start with 6.8, and we're trying to find and as we just saw, that's a 2 conversion problem. Okay, so we need to get into the equation using molar mass, that number right there. So I'm just going to create the ratios. Okay, which of these 2 goes in there? We need to make grams of Ag2S cancel, so it's going to be this one right here. Excuse me, this one right here, the first one. Grams of Ag2S cancels with grams of Ag2S. Now we need to get from moles of Ag2S to moles of H2. So that's the one we've done before a couple times. That's a 1-to-1 relationship. Okay, so which one? We need moles of Ag2S to cancel and moles of H2S to appear on the top. That's going to be this one. Okay, moles of Ag2S cancels with moles of Ag2S. That's the last unit left. That's what we want on our final answer. So now it's going to be 6.8 times 1 divided by 247.87 divided by 1. And we could do this to two significant figures. Sorry, lost my train of thought there. Two significant figures. We have 5 here, 2 here. So 2 is our limit. And that's going to be 0.03. All right, that's the first problem only. These are long, but as you get good at them, you don't have to write all of this. You get to where you learn to set these up quickly. It's a matter of practice. We're doing all this. This is the training wheels that teach you to get there. The graphic organizer is. You'll eventually get to where you know how to set these up quickly. So I'm going to stop this video now, so you have this video to go by, because I'm a day late getting this up. And I'll put the other problems up. There's 2 more that are required. 2 and 3 are required. 4 and 5 are optional if you feel like you need to do them. Okay, so I'll wrap this and get it up for you on Canvas, and I'll continue these solutions later today, Thursday.